Hi everyone, let's take a look at the following limit. Find the cube root of x minus 1 divided by x minus 1 as x is approaching to 1. Step number 1, you plug in x to be 1. And of course, if you do plug in x to be 1, this will give you 0 divided by 0. So again, if you think about this, 1 minus 1 is going to be 0 divided by 1 minus 1, which will be 0. So this is one of the 7 types of indeterminates, and that's okay. So this signals to you step 2 and or step number 3. Now, to avoid the paradox of choice, I'm just going to show you one method in this video, and you can comment below if you have a different method which you find more useful. And again, the approach that I'm thinking about is going to be factoring. So I'm going to write down limit as x is approaching to 1. I keep root x minus 1 in the numerator. When I look at the denominator, I think about the difference of cubes. So specifically, I'm thinking about, and I'll draw a little bubble here so you know what I'm thinking about here. I'm thinking about a cube minus b cube, which basically means I can factor this as a minus b, which is the first binomial, multiply by the trinomial, which will be a squared plus ab plus b squared. So applying this concept, again, the cube root of x is going to be the cube root of x. And the cube root of 1, of course, is 1. And the missing trinomial is going to be, I squared the first term, which is basically x to the power of 2 over 3. Or you can write it as the cube root of x squared, or maybe the cube root of x to the power of 2. You square the last number, 1 squared is going to be 1, and you take the product of the two terms, which is the cube root of x. And of course, you add them. Now, the key is right here. When you do factor, you want to make sure that something can be crossed out from the top and the bottom. So this, again, tells you one thing. You're one step away from getting full marks. Now, again, what happens when I plug in x to be 1? That's going to be 1 divided by 1 plus 1 plus 1, or 1 over 3. Again, make sure you can follow the mechanical steps. When I plug in 1 in here, I'm essentially taking 1 times 1, which is 1, the cube root of 1, which is 1. And likewise, when I plug in 1 into here, I take the cube root of 1, which will give me 1. And of course, I copy that last plus 1. Now, how do we know for sure this is right? Well, I would suggest to everybody spend 1 extra minute to double check. And really, you're activating that dual mindset. So the way I think about this is you can draw a graph and see what is the limit as your x, or what is the limit as you're approaching it from the left, and what is the limit as you're approaching it from the right. So again, if I use a different color, let's sketch a graph for you, which looks roughly speaking something like this. So first of all, notice how there's a cavity or a hole specifically at 1 and 1 over 3, which is kind of what we did from the previous page. We found the answer to be 1 over 3. And if you think about the y-intercept, you can plug in x to be 0. This will give you 0, 1 as the y-intercept. And of course, there is a horizontal asymptote at y equal to 0. You know that because if you look at the exponent from the top and exponent from the bottom, or the degree, if you will, the degree in the denominator is larger than the degree in the numerator. So again, that signals to you the horizontal asymptote, and the function looks roughly speaking something like that. Now, the key is when you look at the left limit and you look at the right limit, it's going to give you exactly the same y value. So specifically, if I go back and label this, this is 1 over 3. And because the left limit and the right limit will give you 1 over 3, we now know for sure the final answer is going to be 1 over 3. I hope this makes sense.